You know, I've been thinking, and space elevators are not feasible. It seems every month or so I find another video on YouTube talking about space elevators. They always point out how we are so close to having the technology to create them and how they will revolutionize access to space. However, I feel they are always overlooking something pretty significant. Before we get into the specifics of the issue, however, let's take a step back so we're all on the same page. A space elevator comes in a couple of variations, but the main one that's talked about involves creating a cable or a ribbon that extends from geostationary orbit down to the surface, and a climber, some device that climbs up and down the cable or ribbon. The benefits of space elevators is that once they are built, they drastically reduce the cost to get to space. They have minimal to no turnaround time, and they are usually proposed to be green technologies, often involving things like solar power and laser or microwave power transmission. The main technology hurdle that everybody talks about is the construction of the cable. To build a cable that is strong enough to support the weight of a climbing device and to extend from geostationary orbit down to the surface is something that we currently cannot do. There are a few different technologies that are talked about for the cable. They generally compare things like carbon nanofibers and Kevlar to some more futuristic and usually theoretical materials. I don't feel that the cable is the biggest hurdle for this proposed method of access to space, however, because if we imagine we already have the technology to create the cable, and if in fact it already existed, we need to talk about climbing the cable as well. When I talk about a space elevator, I imagine most of you are picturing riding in something very similar to an elevator car that we know today. If we use modern elevators as an example, even though they use very different technology because they don't climb up their cable, we can assume a speed of about 1 to 2 meters per second. So, if we can build a climber that could work at that speed, how long would it take to climb the cable? Okay, so here I have to apologize because I have been deliberately a bit vague about this. I've tried to gloss over the fact that the far end of the space elevator is at geostationary orbit, which is about 36,000 kilometers. So now that is a significant distance to get to. If we're going to climb at 1 meter per second, how long will it take to get to the station? Well, there are 3,600 seconds in an hour, so that means you'll be traveling at 3.6 kilometers per hour. Not very fast, I know, but remember, we have to be pulling an elevator car up a cable against the force of gravity. Now, there are 86,400 seconds in a day, so we will only be going 86.4 kilometers per day. That means at 1 meter per second, it will take over a year to get to geostationary orbit. No one is going to want to ride in a 2-meter cube for over a year to get access to space. Now, you could say we've been able to make machines that can travel way faster than 1 or 2 meters a second, and you're right. So let's assume we can build a climber that can travel at 100 kilometers an hour. You have cars that do that every single day of the week. So that seems feasible, but it's actually starting to get into a little bit of fantasy here because remember, we're lifting a device against the force of gravity, 100 kilometers an hour, and it has to go 36,000 kilometers at a trip. When was the last time you drove your car at 100 kilometers per hour continuously for 36,000 kilometers? You haven't. In fact, most people would get their car serviced some time before they would get 36,000 kilometers. But let's do the math. So there are 24 hours in a day, and if we're traveling at 100 kilometers an hour, that's 2,400 kilometers a day. You round that up to make it a little bit easier to 2,500 kilometers a day. You can see that we would be going 5,000 kilometers in 2 days, 10,000 kilometers in 4 days, which means it would be 12 days to go 30,000 kilometers, which would be 14 days to go 35. So a little over 14 days to go 36,000 kilometers at 100 kilometers an hour. Again, I don't see people wanting to take 2 weeks to get to space. Can we go faster? Well, yeah. I mean, we have maglev trains at the moment that average speeds of 300 kilometers an hour. And in fact, maglev is a technology that could potentially be useful in this situation as a means to climb the cable, climb the ribbon. But 300 kilometers an hour would still take 5 days to get to the station. So basically we have this weird situation now. Like all transportation technology that has ever existed, we have this situation that as the time of travel increases, the number of facilities provided and the amount of onboard support increases as well. When you travel in a normal elevator, you're generally comfortable to stand in a 2-meter box because you're only traveling for seconds or minutes at a time. Once the travel time increases, you want somewhere to sit, which means the volume of the container will need to increase as well. Then, as the time increases, you might need access to sanitation and nourishment, further increasing the required volume again. It is around this time that you're also going to start to want some dedicated support staff. So the longer the duration of the travel, the more support facilities that are going to be required. Generally, at the same time, it also becomes more economic if you increase the number of passengers as well. For an example, at the extreme ends, we have the standard elevator car with a capacity of maybe 10 people, going all the way up to an ocean liner, which might be able to accommodate a couple of thousand passengers and staff, but which has a vastly larger volume. So it looks like with our current or near technology, we might need to build something the size of a modern airliner or maybe an ocean liner that can climb a cable at between 100 and 300 kilometers an hour to make this feasible. But even then, I do not see this being realistic for most people who will not want to take several days to get to the space station. Currently, space is available to the select few. However, like all transportation technologies of the last few hundred years, everybody is looking to the commercialization of space. Astronauts and other people may be willing to sit in a capsule wearing an adult diaper for a few days, eating and drinking out of a tube to get access to space. But Joe and Jen public are going to expect more than that. Now, I'm not saying it's not entirely infeasible. It's certainly a feasible solution for cargo. And there are also people, myself included, who would be willing to spend multiple days climbing up to gain access to space. But I don't think that this is going to be used as a regular method for the average person to continually go back and forth to space if it takes several days at a time to do it. Now, while researching this video, I saw another space elevator video that claimed that there was a company currently proposing a solution that had an expected travel time of 8 days, which is in between our 100 and 300 kilometer an hour ranges that we looked at. But again, I don't see this being feasible for the average user. Now, strangely, there is a current technology that we have that might be able to reduce the travel time, but it very much defeats the purpose. You see, a rocket like SpaceX's Falcon Heavy routinely reach speeds of about 36,000 kilometers an hour. So if we slapped a rocket to the climber, it would theoretically be able to push a capsule-sized climber holding a few people to geostationary orbit in about an hour. However, do you see the issues with this? One of the big reasons to build a space elevator is to get away from using rockets. The only way we currently have to quickly get to space would be to use rockets. Now, there are a few questions you might ask, but I'm not an engineer or a physicist. But if I use a bit of logic and reasoning, I can come up with some possible answers. So could you just ride the cable a few hundred kilometers up? Well, no. The answer is because you're not actually traveling, I believe, at orbital speeds until you get to the geostationary space station. Prior to that, you're actually going much slower. I do know that orbital speeds are higher the closer you are to an object, and they decrease as your altitude increases. So if when you were climbing up the cable and you looked out and saw a satellite or another space station, you would see it whizzing by incredibly fast because it's actually going several thousand kilometers an hour. If you jumped out of the climber at any lower altitude, you would essentially have minimal or no orbital velocity, and you would simply just plummet back to Earth. It's not until you arrive at the geostationary space station that you would actually get the same orbital velocity as the space station and be able to leave without falling back down to Earth. Okay, so what if we travel up a few hundred or a few thousand kilometers and then launch a smaller rocket from there? That would certainly work, but you introduce major risks of damaging the cable or the climber or both. And then the only way to get that device to get back down to the ground would be to have it, come down like a normal rocket. It would be way too dangerous to try and get it to reattach to the cable and climb back down the rest of the way. So, as we can see, with current technology, it appears that this is just not really feasible for everyday use. It seems like it's a dead end or just something that is going to be used by the select few. I'm not an engineer or a physicist, so is there something I'm missing? Or is it just that there are enough people who are interested in sitting in a small room for a week, one way to get to the space station before they go anywhere else? I don't get it. Yes, I would be willing to ride the space elevator to get access to space, but I also feel it's not something that everybody, it's not going to be as ubiquitous as an aeroplane or any other form of mass transit that we talk about today. Until we can have some way of easily getting to and from space quickly, this is an in-between. I'm not sure what it is. And I'm not sure it's really worth the money people are throwing at it. I don't know. Am I wrong? Leave your comments down below. Tell me what you think. Is it something you would be willing to do? Riding potentially for days on end, each way, up or down a cable to get access to space? So these are just my thoughts. I hope you enjoyed this video. Please comment down below, and I'll see you next time. Thanks a lot. Bye.